Hi, this is a recorded presentation for the breakout session, Who Didn't Respond? Analyzing Non-Response Bias in Survey Data. I'm Tamara Nimkoff, joined by my colleague Ben Schneider, and we represent the IDA Data Center. IDC is an OSEP-funded technical assistance center that works with states to improve IDA data collection and reporting. And we support states in the analysis and the use of those data. Over the next 30 minutes, Ben and I are going to talk about the importance of identifying and reducing non-response bias in surveys. We'll briefly overview the concepts of data representativeness and non-response bias, and we'll walk through an example of how to identify and reduce the negative impact that bias can have in the quality of your survey data for IDA. We'll also preview a new technical assistance tool that IDC is developing just for this purpose. So while the topic of non-response bias is really applicable to any survey data collection, it might help for us to talk about it in the context of a data set that you're likely already very familiar with, which is the parent involvement data set. Among the many child outcomes that states must collect and report data on within their SPPAPR is this Part B Indicator 8, which is the extent to which parents report that schools facilitated their parental involvement as a means of improving the services and results for their children with disabilities. Now, most states use surveys to collect this information. And these surveys are a relatively efficient way to collect information from this large number of parents of students with disabilities within their state. But surveys, of course, only provide estimates of actual population values. And we want our survey estimates to be as accurate as possible a representation of our whole target population. So we can frame our approach in order to improve this accuracy through these guiding goals of high quality survey data collection. This includes capturing the full experience of our target population through the collection by using survey methods that make it equally likely that all of our groups of potential respondents are able to participate, and thus increasing our confidence that the findings from those people that took the survey actually represent and therefore can generalize to the rest of our population. Now, every survey is subject to some kind of bias, which broadly speaking is systematic error in our data, such that the estimates are consistently too high or too low. And bias cannot be completely avoided, but it can be reduced and mitigated with the above goals in mind. By improving equity and access in our surveys, however, requires intentionally examining the quality of the survey data. Now, each year, states examine their survey data for this purpose of ensuring data quality, looking at the representativeness of their data, their response rates, and as a fairly new requirement, examining for the presence of non-response bias. So for example, with respect to the parent involvement indicator 8 data, states need to describe the extent to which the demographics of the children of responding parents are representative of the demographics of the children receiving special ed services statewide. States need to describe the strategies that they are going to be implemented to increase the response rates year after year, particularly for subgroups that are shown to be underrepresented. And states need to analyze the response rate, including looking for any non-response bias, and describe the steps that can be taken to reduce that potential bias and thus promote a response that represents a broad cross-section of children with disabilities in their state. So let's first think about representativeness and this requirement. In OSEP's requirement, the term representativeness means that the data are collected reflecting the population being surveyed. So a key point is that a sample can be representative with respect to some characteristics, but not to others. And so your strategy to assess representativeness is to disaggregate or break down the data for an understanding of the subgroups by those key characteristics. So we're going to look at an example. Here's an example with indicator 8 demographic data. When you disaggregate the survey results here, you can see that respondents are not representative of the population with respect to student race. So in this example, in the table on the with race and ethnicity, parents of Hispanic children with disabilities were underrepresented in the survey. You can see they have a response rate of 9.9% compared to their population, where they make up 18.8%. So parents of white children, on the other hand, made up 69% of the survey respondents. However, in the population, they make up 61.9%. So that group is overrepresented. However, when you look at these same exact survey data by disability category, you can see that they are representative with respect to disability category. So when you look at the response rates across the survey data and the response rates in the population, you can see that they are generally proportional. So one strategy to ensure that you're capturing your full experience of your target population is to take your overall response rates and actually break them down into response rates by key subgroups on those important variables. What are those important variables? Well, that is really determined by the context of your state, but student race, ethnicity, and disability category often are found to be very key variables. When you have survey data that are representative, they can be generalized with more confidence to your population. One of the major factors that can affect representativeness of the survey data relates to survey non-response, which Ben is going to talk more about.
Thanks, Tamara. This is Ben. I'll be discussing non-response bias, and I'll be demoing the tool today. I'm a statistician with Tamara at IDC and at Westat. Now, OSIP's requirement to analyze non-response bias is new, and so the concept of non-response bias may be unfamiliar to some of us. So let's take a minute to clarify what the term non-response bias means. Non-response means that the response rate for a survey is below 100%. When you invite a sample of persons to complete the survey, not all of them do so. That's straightforward. But what about bias? Bias is systematic error in an estimate that causes it to be too high or too low. Here's an example. Suppose that in our state, some 25% of students with disabilities enter post-secondary education each year. Each year, we conduct a survey to measure post-school outcomes with a margin of error of plus or minus 5%. One year, the survey estimates that 20% of students with disabilities enter post-secondary education. The next year, the survey estimates that number to be 30%. Each year, the survey is off by 5 percentage points, but the error is not systematically too high or too low, so we wouldn't call that bias. Suppose instead that in the first year, the survey estimates the number to be 30%, the next year 32%, and the next year 31%. Each year, the survey estimate tends to be too high. That's bias. So altogether, non-response bias is bias, systematic error, specifically caused by non-response to a survey. Now, how does non-response cause this systematic error? Two things must both occur. First, certain subpopulations are systematically underrepresented. For example, suppose that students who are Hispanic or Latino make up 20% of the student population, but their parents have consistently lower response rates than other parents, and so make up only 10% of the respondents to the parent involvement survey. Then we would say that they are systematically underrepresented. That's the first of two things that has to happen for non-response bias. The second necessary condition is that the subpopulations, the underrepresented ones and the overrepresented ones, have to differ in terms of what we're trying to measure. This would be the case if, for example, perceptions of school involvement are lower for parents of Hispanic Latino students than for other parents. Now let's turn to look at some of the implications of this definition. First, the problem in non-response isn't low overall response rates to a survey. You can have a very low overall response rate and not have non-response bias. The problem is when there are systematically uneven response rates across groups. If that happens and these groups differ in what we're trying to measure, the non-response bias is inevitable. So what can we do about non-response bias? Well, we can't control whether the subpopulations differ in what we're trying to measure, but we can control whether subpopulations are underrepresented in the survey. During the survey design and data collection stage, we can work to prevent some groups from having lower response rates. For example, we can make sure to provide multilingual questionnaires and recruitment materials. We can provide multiple modes of interview, online, paper, telephone, depending on what is most accessible to different subpopulations. After data collection is closed, we can improve our method of data analysis. Specifically, we can use statistical weighting adjustments to give underrepresented groups greater influence on estimates to make up for their smaller sample size. This requires us to have some data that tells us which groups are underrepresented in our sample. And all of these strategies can be used together. Now let's look at an example. We'll try and illustrate how non-response bias occurs using this example table. Let's consider indicator B8, that is, the percent of parents with a child receiving special education services who report that schools facilitated parent involvement. Let's suppose that the actual true value of indicator B8 is 51.1%. In other words, if we got a survey response from every single parent in the population, we'd find that 51.1% of them would agree on indicator 8. This slide shows the overall population percent in the box at right. Now, that 51.1% figure is for the overall population. That percent can vary across different subpopulations of parents. In this table, the column labeled percent agreement on indicator 8 shows how agreement varies for different groups of parents. In the example data on this slide, 59% of parents of white students agree on indicator B8, but only 25% of parents of Hispanic students agree on indicator 8. In practice, we'll never measure agreement on indicator 8 from 100% of the population. When we conduct a survey, we'll only measure agreement from a fraction of the population, the survey respondents. In our example, the percent agreement for indicator 8 in the population is 51.1%. Ideally, the percent agreement for indicator 8 among survey respondents would exactly match the population. However, in our example, the percent agreement for survey respondents is 54.8%. In other words, our survey estimate is too high. Why is the estimate too high? In our example, it's because of non-response bias. We can clearly see why there's non-response bias here. The two requirements for non-response bias are both present. First, there's systematic underrepresentation. As we can see in the table column titled percent of population, parents of Hispanic or Latino students make up 18.8% of the population. Yet they make up only 9.9% of survey respondents, as we can see in the column titled percent of respondents. These parents are underrepresented. Second, the underrepresented group differs in what we're trying to measure. In the population, agreement on indicator 8 is much lower for parents of Hispanic or Latino students, 25%, than for other parents. So we have systematic underrepresentation and differences between the underrepresented group and other groups, and thus we have non-response bias. One strategy for reducing bias after the survey data have been collected is to use a non-response weighting adjustment. Without weighting, parents of Hispanic Latino students have too little influence in our data because they're underrepresented. With a weighting adjustment, we ensure that the underrepresented group is assigned more weight so that its influence in our data is exactly proportional to the size of that group in the population. In this example, we'd assign a weight equal to the group's percent of the population divided by the group's percent of respondents. The Hispanic or Latino group gets a weight of 1.89, which we can see in the column of this table titled weight adjustment. And this weight is calculated by taking the population percent, 18.8%, which is 1.89 times the size of its sample percent, so dividing the population percent by the sample percent. When we use the weights to calculate percent agreement for indicator 8 based on data from survey respondents, our percent agreement becomes 51.9%. In this hypothetical example where we know the true population percent agreement is 51.1%, we can see that the weighting adjustment has helped reduce non-response bias. In practice, we don't know the true population percent, so we won't know for certain that weighting has reduced non-response bias. Nonetheless, weighting is a valuable tool for assessing and reducing non-response bias. When sample percentages change significantly after weighting, this is frequently indicative of non-response bias or other representativeness problems with the unweighted data.
Great. Thank you for sharing that example, Ben. We wanted to walk through a hypothetical example showing how the survey data can be disaggregated to examine response rates, to assess for representativeness, and to look for and potentially reduce non-response bias. But to help states continue to improve the quality of their data underlying their APR indicators, IDC is actually developing an interactive application that runs several of these analyses. In the next 8-9 minutes, Ben is going to now demonstrate running analyses related to these same key questions that we just walked through. Questions related to assessing representativeness of the data and assessing and reducing potential non-response bias.
Thanks, Tamara. I'm going to share my screen to show the use of the tool. In this demonstration, I'll show how the interactive application can be used to analyze representativeness and assess non-response bias analysis. We'll use an example data set that's the same as the examples we've seen so far and is based on a parent involvement survey measuring agreement for indicator 8, using a simple random sample of 5,000 parents. At the end of this demonstration, we'll have an Excel report summarizing our non-response bias analysis. The application has a point-and-click interface available on the user's web browser, such as Google Chrome, which you can see here, and is run using RStudio, which is a free open source data analysis program popular among analysts and data scientists. Once the application is loaded in the web browser, a welcome page appears with instructions on how to use the application. The application consists of 3 modules, which we can see at the top of this page: Setup, Analysis, and Report. In the Setup module, we load our survey data and prepare it for analysis. After completing the setup, we use the analysis module to conduct an analysis by configuring options such as which groups we'd like to calculate response rates for. When we're satisfied with an analysis, we can add it to a running report. And after completing all of our analyses, we use the report module to export an Excel file summarizing the analyses. Let's get started. We begin the setup by loading our survey data from a file. Here, we'll load our data from a CSV file. The application summarizes the number of rows and columns in our data and tells us the list of variables available in the data. We can also preview the first few rows and columns of the data set. Here, we can see that the data consists of parents from various schools and school districts, and some parents are classified as respondents, while others are classified as non-respondents. Next, we'll identify the data collection method so the application knows how to properly analyze the data. Since these data come from a random sample, we select the survey sample option. Next, we need to instruct the application how to identify which parents are respondents or non-respondents. This is important for calculating response rates and conducting other related analyses. We select a variable giving the response status to the survey, and we instruct the application how to interpret each category of that variable. If our survey used a complex sampling method, such as stratification, clustering, or oversampling, we can select additional configuration options to ensure the data are analyzed properly. Since our data are a small, simple random sample, we can ignore these options and simply proceed to the analysis module. The analysis module lists several different types of analyses we can conduct, with each analysis grouped according to the research question it addresses. We'll start by calculating response rates for different subgroups. To calculate response rates for different categories of parents, we'll select the student race variable as a grouping variable. There are a few additional options we can use to precisely control how response rates will be calculated, but for this demonstration, we'll use the default options. Once we're satisfied with the options we've chosen for the analysis, we can select the Submit button to view the analysis results. Here, we have a table of response rates calculated separately according to the race of the parent's child. As we saw in the example earlier in this presentation, parents of Hispanic or Latino students have much lower response rates to this survey compared to other parents. 32% compared to 68% among parents of white students, for example. This table indicates that parents of Hispanic or Latino students may be systematically underrepresented among respondents. To save this table to a running report, we select the Add button. Now, we can go to the Report module and see that the response rate analysis has been added as an item in a report titled Calculate Response Rates by Subgroup, Student Race. When we're done with all of our analyses, we'll select the Save to Excel option in the Report module to generate an Excel report. But let's do an additional analysis. We'll compare student race and the respondent data to an external benchmark dataset to see if parents of Hispanic or Latino students are underrepresented among respondents relative to their percent of the population. We'll select student race as the variable we want to analyze, and we'll indicate that this variable is categorical. We can now enter in external benchmarks for the population percentages, which are taken from the PowerPoint slides that we saw earlier. So for example, we have parents of American Indian or Alaska Native students are 0.9% of the population. In addition, we can select a statistical test to use for checking whether differences between the respondents and these benchmarks are statistically significant. Let's view the analysis results. This analysis table summarizes the percentages among respondents and compares them to the external benchmarks. We can see, for example, that parents of Hispanic or Latino students constitute 9.9% of the respondents, but are 18.8% of the population according to our benchmark data. They're underrepresented by about 9 percentage points. The p-values of statistical significance tests indicate that there is strong evidence that there's a statistically significant difference between respondents and the population in terms of the percent of parents of Hispanic or Latino students, and in terms of the percent of parents of white students. Let's add this to the report. Now, let's see if weighting adjustments using the benchmark data can help reduce non-response bias. We'll select an analysis type which compares estimates before and after weighting adjustments. Now there are some statistical details of how to evaluate the weighting adjustments which we could configure, but for this demonstration, we'll use the recommended default options. To conduct the weighting adjustments, we select a variable to use for weighting, in this case, student race. Next, we select a variable in the data which gives population benchmarks for each category of student race. In this case, student race benchmark. Finally, we select a variable whose means or percentages we'd like to compare before and after the weighting. In this case, that's a variable for indicator 8, named whether a parent agrees. Some of the more complex analyses, such as this one, can take a few seconds to process in your computer. Now we can see that before the weighting, the percent agreement, which is this first row in the data, was estimated to be about 55%. After weighting, the percent agreement is 52%. The weighting made a significant difference in our estimate for indicator 8. Let's add this to the report. Returning to the report module, we now have all of our analyses saved and ready to report and ready to export to Excel. This may take a few seconds. We're going to open up Excel and see what this looks like. The report has a table of contents listing all the analyses that we conducted earlier. For example, the table of response rates, comparisons of respondent to the benchmarks, and the estimates before and after weighting adjustments. We can view the table for a specific analysis, which gives the table that we saw earlier in the app, as well as some additional detail about all of the data that's been produced by that. With these materials, we're now ready to report on our non-response bias analysis and the representativeness of our data. I'm going to turn this back over to Tamara to discuss how we can use these findings.
Thanks so much, Ben. We're really excited about this tool in its beta version, such as it is, and the applications of it in the future. Practically speaking, how can a state actually use the results of these analyses that can be calculated? Well, firstly, through in the sense of reporting to OSEP and sharing with broader stakeholders. Because there are so many different ways to run a survey, it's really important to be transparent, not only about how a survey was conducted and data were collected, but also how the data were analyzed and the resulting characteristics of those data results, so that the state and the state's broader stakeholders can know how to best interpret the results and draw conclusions from their data. So for an example, in reporting in this parent involvement example, the state might choose to report something like this, that the parents of students with disabilities who are Hispanic Latino made up 10% of our survey respondents, which was significantly lower than are represented in the population at 19%. The agreement on indicator B8 further was lower for those respondents at 26% than for the overall respondent agreement of 55%. So because that subgroup is underrepresented and agreement is different for that group than other groups, there's a risk of non-response bias in the data. The state would then report that they use statistical weighting to adjust for that underrepresentation of the group, that the weighted estimate of parent agreement was 52% compared to the unweighted estimate of 55%. And the state would want to report both the unweighted and weighted estimates because the weighted estimates are going to be, in this example, likely a more accurate representation of the actual value in the population. So beyond reporting, they're in sharing, of course, the results of these analyses of representativeness and non-response bias can be used and should be used to improve future procedures for collecting and analyzing data. So for example, in our parent involvement survey, the state might decide that more accurate data will be achieved by including Spanish in the survey invitation and follow-up contact attempts during their data collection. And after data collection, they may decide that it is prudent to use population data on race and ethnicity to conduct weighting adjustments like we've shown. So there are many examples of steps that a state can take to better capture the full and more accurate experience of their target population. Identifying and reducing non-response bias in their survey can be a key part of this. By improving the quality of the data that underlie the APR indicators, states are in a much better position to use those data to inform programs and to ensure that improved outcomes for students with disabilities and their families occur. So we want to thank you so much for attending and viewing this presentation. Ben and I look forward to talking more about this topic and answering any questions that you might have during the conference roundtable discussions. Feel free to contact either of us for further information or go straight to the IDC website where you can find a full range of resources and technical services available. And we want to thank you both. Thank you so much for your time today.